Okay, hello everyone. So in this video I'm going to teach you how to convert between real and imaginary to magnitude and phase and vice versa. So how to get, if you're given a complex number, how to find the magnitude and the phase of this complex number, given that it is presented to you in the form of real and imaginary parts. Okay, and the other way around, how to get the magnitude, how to get the real and imaginary parts if it was given in the polar form, which is magnitude and the phase. Okay, so given a complex number z, it is given as x plus jy, okay, and it is in the form of r to e to the j theta, if it is given in a polar form. If you want to find this value, the value of the r and the value of the theta, given x and y, the value of r is equal to the square root of x squared plus y squared under the square root, and the value of theta is equal to the arctangent of y over x, so the tan inverse of y over x. Okay, so what if you're given r and theta, r e to the j theta, and sometimes it is given on this form, r theta. Okay, in that case, you need to find the value of x and y. X equals r cosine theta, and y equals r sine theta. Okay. The definition of r is the magnitude. Sometimes it is referred to as the absolute value of z. Okay? Theta is the phase, which is the angle of z. X is the real part, and y is the imaginary part. So these are basically the rules that we're going to be using. Okay? And from now on, we're going to solve, till the end of this video, we're going to solve some examples. Okay? So given z equals r plus j, 3 plus j4. What is the value of the magnitude and the phase? The magnitude is equal to square root of 3 squared plus 4 squared. Okay, and this becomes, so that's the magnitude, and that is the phase. Okay. Here is the phase. What is the value? What is this value? Put it on the calculator. You'll find that absolute value of z is equal to 5. Okay. What is theta? Theta is equal to tan inverse y over x. What is y? Y is the value associated with the j. Y is the value that is multiplied by the j, which is equal to 4. Okay. Over x, which is equal to 3. Okay. Put this on the calculator and find out what this value is going to be. Okay? So, and this means that 3 plus j4 is equal to 5 e to the j theta. And this value is put here. Okay? So, remember that this value could be in radians or could be in degrees. Okay? But if you are going to use it, if you are going to put it on this form, this has to be in radians. Okay? And if you are going to put it on this form, this could be a degree or could be radian. Okay? Degree or radians. Degree or radians. Okay? So this form has to be radians, and this form it could be degrees or radians. It doesn't matter. Okay? So, let's take another example to illustrate this idea. Let's see if we have z equal to 1 plus j2. Or let's see 1 minus j2. Okay? So in that case, absolute value of z equals 1 squared plus 2 squared under the square root, which is equal to square root of 5. Okay, and that's the value of the magnitude. Value of theta equals tan inverse y, which is negative 2, over 1, which is negative tan inverse 2. Okay, so if you want to find this value, you could put it on the calculator, or you could use your trigonometric information or experience. In that case, what is the value of theta? If you know that if you have a 30, 60 degrees triangle, then if this is 1, this is 2, and this is root 3. Okay? So what is the value of theta that has a tan is equal to 2? So that's basically this question. Forget about the negative for the time being. We want to find the value of tan inverse 2. Tan inverse 2 is a value of let's say that it's equal to y, or equal to, let's say, alpha. Okay, which means that 2 equals tan alpha. So in order to find the value of alpha, once you find the value of alpha, alpha is equal to negative theta. So theta will be the value of negative alpha. So we need to find the value of alpha. What is the value of alpha? What is the angle that has a tan is equal to 2? Tan is equal to 2 means that opposite over adjacent. Opposite 2 over 1. Okay? 2 over 1, which means that alpha is 60 degrees. Okay? Because tan 60 is equal to 2. Tan 60, opposite over adjacent, is equal to 2. Okay? So in that case, alpha is equal to 60 degrees, and thus theta is equal to negative 60 degrees, which is equal to negative pi over 3. So this is with the degrees, and this is with the radians. Okay? Whether you write it degrees or radians, it doesn't really matter that much. But once you put it in the form of e to the j theta, then in that case 1 minus j2 is equal to root 5 e to the j theta. What is theta in that case? You cannot write it negative 60 degrees because it's in this form. We have to write it negative pi over 3. Okay? That's mathematically more correct. But you can write it negative 5 pi over 3, or you can write it square root of 5 negative 60 degrees. Okay? All of these are equivalent. So in this, the reason why we were able to find the exact value of the theta is because I know this property of the triangle. But in that case, I do not know what the value is. If that is 3 and that is 4 over 3, I do not know what this value is. So this is 5, but I do not memorize this value. So you can put it on the triangle, put it on the calculator, and find the value. Okay? So let's take another example. And this example, what I'm going to do is that I'm going to not put it neither on this form nor in that form. Okay? So z is equal to, let's say, 1 minus 2j multiplied by 3 plus 5j. And I want to find the value of the magnitude and the phase. What are these values? Okay, so first of all I need to put it in this Cartesian form. Okay, real and imaginary parts. So 1, I need to expand the brackets. 1 by 1 is 3. 1 by positive 5j is positive 5j. Negative 2, so negative 6j. And then negative 10j squared. J squared is equal to negative 1. Why? Because j is equal to square root of negative 1. So j squared is negative 1. So this 3 plus, this is minus 1j, minus j, minus 10 multiplied by negative 1. So this makes 13 minus j. Okay? So that is the value of the complex number z, which is equal to these two parentheses multiplied together. Okay? So let's find the value of the magnitude. Magnitude is equal to 13 squared plus 1 squared. Of course it's a negative 1 squared, right? Under the square root. And remember that here it was supposed to be plus negative 2 squared. But it doesn't really matter the negative. Why? Because that's a negative 2. 1 plus j, negative 2. Okay? And that is the main reason why I put here a -2. Okay? Similarly, that's what we're going to do here. So 13 squared plus -1, because that's -1 multiplied by j, okay, which is equal to 169, right? 169, so 170, square root of 170. Okay? So you can put this on the calculator and find the value. It's going to be 13 point something. Okay? Roughly speaking. And the value of theta is equal to tan inverse y over x. What is the value of y? -1 over x, which is 13, and thus you can calculate this value either in radians or in degrees. Okay? So that's how you do the conversion. Last example to convert from the radians to the degree, from the real imaginary to the polar form, which is magnitude and phase, is when you're given this example, 1 over 1 plus j 2. Okay? How do we calculate this value? This is not on the form of magnitude and phase. Okay? However, we are going to convert it to, this is not on the form of magnitude and phase, and we want to find the value of magnitude of z and the value of theta. Okay? And the value of theta. Okay? However, you do not know what the value of x is and what the value of y is. Okay? So what do? We first convert this number. Okay? Let's find a number, let's find z, which is, let's call it z1, okay, which is equal to, this is z1, 1 plus j2, okay, which is, and thus the absolute value of z1 is equal to 1 plus 2 squared under the square root, okay, so it becomes square root of 5. And the value of theta 1, which is the angle of this number, okay, what is this value? It's equal to tan inverse 2 over 1, okay, and this is equal to 60 degrees, okay, this is equal to 60 degrees, okay, so which means that z1 is equal to square root of 5 e power j, which is equal, this is equal to pi over 3 j pi over 3, okay, which means that z is equal to 1 over z1 from this relation, okay, which is equal to 1 over square root of 5 e power j pi over 3, which is equal to 1 over square root of 5 e power -j pi over 3. Why? Because when we take this from the denominator and move it to the numerator, we get a negative sign. So this becomes the magnitude, and this whole becomes the phase, the negative sign multiplied by the pi over 3. So the magnitude of z is equal to 1 over square root of 5, and the phase becomes negative pi over 3. So the difference between z1 and z is that z1 has a magnitude that is the reciprocal of the magnitude of z. So z1 has z1 and z have reciprocal magnitudes, okay, one over the other. And theta is the difference between the theta and theta 1 is the negative sign. So this is negative pi over 3, and this is pi over 3. Okay, so that's how you do it. So when you find a number in the denominator, all you need to do is take find the magnitude of this number and the phase of this number, and the magnitude of the number that you're looking for is equal to 1 over that magnitude. Okay, 1 over the magnitude that you found, and the theta is the negative value, and that's basically why when we have a number, let's say z is equal to 1 over j theta, or let's look at this example, 1 over j 3. What is the magnitude of this number? Here it is 0 plus, okay, which means that magnitude is equal to 0 squared plus 3 squared, then it is equal under the square root, which is equal to 3, right? And the phase is equal to tan inverse y, which is 3, over x, which is 0, which means that it is equal to tan inverse of infinity is pi over 2. Okay, so that's the tan inverse of infinity. Okay, so what if you have z is equal to 1 over j 3? Okay, then in that case you expect that absolute value of z is equal to 1 over the absolute value, and let's assume that this is z1, so absolute value of z1, okay, and this is theta 1, so z is equal to absolute value of z1, right, which is equal to 1 over 3, okay, and theta is equal to negative theta 1, which is negative pi over 2, okay. So this is basically how you get the magnitude and the phase from the numbers. Okay. Last example to convert from the magnitude and the phase to the real and imaginary parts. Given that theta is equal to 5, z is equal to 5, e to the j pi over 6. Okay, and here let's put a negative. Okay, so what is the value of x and what is the value of y? Okay, I need to write this in the form of x plus jy. Okay, the value of x equals 5, which is the r. Okay, multiplied by cosine theta. What is theta? Cosine negative pi over 6. Pi over 6 is, the value of pi over 6 is 30. Okay, so that's negative 30 degrees. Cosine 30 is equal to 3, square root of 3 over 2. Okay, which is the final answer of x. Okay, or you could do the approximation by the decimal. Okay, and what is the value of y? Y is equal to r sine theta, which is equal to, what is the value of r? R is equal to 5, right? And sine negative 30 degrees. Okay, which means that it is equal to negative 5 multiplied by half. Okay, because negative 30, you put the negative outside, so it becomes negative half. Okay, so let's do this on more steps. So forget about the negative. Okay, becomes negative sine 30 degrees, which is equal to 5 negative half. Okay, 5 multiplied by negative 2.5. Okay, why is that? Because sine 30 is equal to half. The sign doesn't affect the negative. The negative comes out. You can factor the negative out. But for the cosine is an even function. Thus, cosine negative theta is equal to cosine theta for any value of theta. Okay, and this becomes the number. So in that case, z, which is equal to 5 e power negative j pi over 6, is equal to 5 square root of 3 over 2 minus j 2.5. Okay, so that is polar and that is Cartesian. This is in the form of real and imaginary parts. Okay, so hope you guys this video has made it more clear on how to convert from these two forms of complex numbers, and please let me know if you have any questions. Okay.